Hello everyone, I'm Adam. In this problem, we're going to be using the triple scalar product to find the volume of the parallelepiped with adjacent edges given here by our vectors u equal to the unit vectors I plus j, and v equal to the unit vectors j plus k, and w equal to unit vectors I plus k. And so specifically how we're using the triple scalar product is we know that the volume of a parallelepiped with adjacent edges, say u, v, and w, is the absolute value of the triple scalar product. So this here is our triple scalar product, the dot product of u with v cross w. So essentially our work is pretty straightforward. We're going to find the triple scalar product, find what constant that's equal to, and then take the absolute value of that, and that gives us our volume. So before we get there, let's see what we actually have in terms of u, or component-wise. So I plus j, so u is going to be vector with, say, components 1, 1, and 0, and v, j plus k, is going to be a vector with components, say, 0, 1, and 1, and w, we have a vector with components, say, 1, 0, and 1. And so why we need those is to find our triple scalar product. All right, so our u dotted with v cross w, well, this is equal to the determinant of the 3 by 3 matrix made up where each row consists of the components of each of our vectors u, v, and w. So our first row is going to be our components of u, say 1, 1, and 0. And second row, components of v, 0, 1, and 1. And lastly, last row, components of w, 1, 0, and 1. So we're taking the determinant of this 3 by 3 matrix, right? And how we do this is we start in our top row with our first entry and essentially kind of delete that column and row with that value in it and take the determinant of the 2 by 2 matrix with what's left and that value multiplied. And we start with positive, so positive 1 times the determinant of our 2 by 2 matrix, determinant of our 2 by 2 matrix with 1, 1, 0, and 1. And then we start alternating signs, so minus, taking the next value, kind of taking out that row, or sorry, that column and that row. So minus 1 times the determinant of what's left. So our row would be 0 and 1, and then 1 and 1. And plus, the last entry is 0, and times the determinant of the 2 by 2 matrix made by taking that column and that row out. So we'd have first row 0, 1, and say 1, 0. Okay. So let's go through, and we're just going to find the individual determinants of our 2 by 2 matrices. So we're going to have 1 times, so the time to determine here, and the determinant from a 2 by 2 matrix, what we multiply down the first diagonal and then subtract what we would have multiplied with the second diagonal. So 1 times 1 minus 0 times 1 would just leave us with 1, and minus 1 times 0 times 1 is 0, minus 1. So we have a negative 1, and plus, really we don't have to do this because 0 times anything is 0, but we'll go ahead. We have 0 times 0 minus 1 times 1, so it would be negative 1. Okay, so what do we have putting this together? So 1 times 1 is 1, negative 1 and negative 1 is plus 1, and so we get our triple scalar product equal to 2. So the triple scalar product comes out to be positive, but just to be technical, so our volume of our parallelepiped, right, is the absolute value of our triple scalar product. So the absolute value of 2, which is just 2. So there we have it. Thank you very much.